Alright guys, here's the Spiral 6 review for precalculus. We're going to start by identifying and graphing some other functions. And the first one we're going to take a look at is negative x cubed plus 3. First thing I'm going to draw in red is going to be the mother function x cubed, just so we have an idea of what it looks like. And in blue I'm going to use the plus 3 to shift it up 3, and the negative out in front to flip it upside down. So if that's 3, this is going to be flipped upside down and look like this. Our second question asks us to identify a graph based on the mother function. Okay, we know this mother function is the square root of x. The first thing that's happening is it's being flipped vertically, so we know that this guy is going to involve the negative square root of x. If I look based on where my original endpoint was and where my new endpoint was, that's 2 units to the left. That's going to be a square root of x plus 2 inside my square root. And the last thing we need to take a look at is the steepness. At first it went up 1 over 1. Now it goes down 3 over 1. So it's going to be a negative 3 square root of x plus 2. My next set of problems is based on some operations on functions. My first one is f minus g of x. That means I take f of x, 2x squared minus 2, and from that I'm going to subtract g of x, which happens to be 27 plus 2x. I can simplify that a little bit. 2x squared minus 2 minus 27 more is going to be minus 29, and then I have a minus 2x. My next one is going to be based on dividing two functions and plugging in a value. So we've got g over m, so that's 27 plus 2x over negative x squared plus 3. Plugging in negative 2, because that's what that means, it's 27. 2 times negative 2 is negative 4 over negative 2 squared is going to be negative 4 plus 3. That's going to reduce into 27 minus 4 is 23. Negative 4 plus 3 is over negative 1. That equals negative 23. Next problem, m of g of x. In other words, we're plugging in g of x into m. So if I've got m, which is negative x squared plus 3, I made my x nice and big there, because what I'm actually going to do is literally erase that x and plug in g, which is 27 plus 2x. That satisfies me. You don't need to do any more than that. Okay, then I ask you to do g of m of 8. First thing I might do is to find m of 8, which equals negative 8 squared plus 3. Negative 8 squared is 64. Negative 64 plus 3 is negative 61. We're going to take that and plug it into g. G is 27 plus 2x, so 27 plus 2 times negative 61. 2 times negative 61 is negative 122. 27 minus 122 is going to be negative 95. Next problem. We've got to factor each expression completely. If I look at my first problem, I've got 15x squared and minus 48. That is a quadratic, but I don't have a lot of clues there. One thing I could do would be to take a look and I see, okay, that's a multiple of 3. That's a multiple of 3. I could write this as 3. 5x squared, and 48 divided by 3 is going to be 16. It was not my intent, but I made a problem that only factors that much without going into some non-integer answers. Okay, for my next trick, I'm going to look for two numbers that multiply to negative 84 and that add up to 17. Okay, numbers that multiply to negative 84. Well, I've got 84 times 1. I've got 42 times 2. And those are negative 1 and negative 2. I've got 21 times negative 3. Except that's not negative 3, that's negative 4. And there we have a winner. I'm going to make that 4 a little bit nicer looking. There we go. 21 plus negative 4 is 17. Okay, so I've got 7x squared plus 21x minus 4x minus 12. My first two have a 7x in common. I've got an x left and I've got a plus 3. I can pull a minus 4 out of my next two and I've got an x and a plus 3. 7x minus 4, those are my leftovers, and x plus 3. That is my fully factored solution. Next problem is asking us to solve an equation. The first thing I'm going to do is move everything over to the same side. Generally, I like keeping the x squared positive, so I'm going to move those two guys over and make them negative. 13x squared minus 64x plus 5 equals 0. Okay, I'm going to look for two numbers that multiply to get, okay, 13 times 5 is 65, and add up to negative 64. Alright. Oh, I'm sorry, this should be negative 5. So negative 65 that add to negative 64. That makes me much happier because there we get the numbers negative 65 and 1. Okay. So 13x squared minus 65x plus 1x minus 5. I'm going to have 13x coming out of that, x minus 5, and I've got a plus 1 coming out, x minus 5 equals 0, 13x plus 1, and x minus 5 equals 0, 13x plus 1 equals 0, and x minus 5 equals 0. I can bring the 1 over. I can divide by 13. I get x equals negative 1 divided by 13, and x equals 5. Those are my two solutions. Same process for all of these, where we factor, and then we set them equal to 0 and solve. Now we're entering the world of complex numbers. First thing I have is a quadratic that with only an x squared I could probably get away without actually factoring. I notice that both of those guys are even. I could divide everything by 2, and I get x squared plus 16 equals 0, minus 16 to the other side, and I get x squared equals negative 16. Square root both sides. I get x equals plus or minus the square root of negative 16. We know that square root of negative numbers are going to involve an I, so we could write that as plus or minus I times the square root of 16. I could also write that as plus or minus I times 4. Simplifying this expression, most of the time remember that we treat imaginary numbers a little bit like variables. So I can double distribute and I get 15. 3 times 2i is 6i. Negative 6i times 5 is minus 30i. Negative 6i times plus 2i is minus 12i squared. Here's one of the times that you cannot treat an I like a variable, because I squared equals negative 1. Please remember that I equals the square root of negative 1, so if you square it, you get a negative 1 out. Okay, so if I plug this stuff together, I've got 15. 6 minus 30 is minus 24i, and then minus 12 times I squared negative 1. Let's be plus 12. 15 plus 12 is 27. 27 minus 24i, and I'm done. Our last section, completing the square and using the quadratic formula. To complete the square, the first thing that you need to do, and this is kind of set up in a nice way for you, is take a look at your b term and divide it by 2, and I get 7. We're then going to square that, and what I wish I had was a 49 as my last number, but I don't, so I'm going to have to add that in. Okay, if I do plus 49 on the left, plus 49 on the right, I've got x squared plus 14x plus 49 equals 36. That's going to give me 36, and if I factor the left side, I'm going to end up with x plus 7 times x plus 7, which I could write as x plus 7 quantity squared. Right, so to get rid of that squared thing, I'm going to square root both sides. I end up with x plus 7, my squared and my square root are going to cancel out, equals a positive or a negative 6. That's going to provide me with 2 answers, and I'm going to go up to the next column a little bit to show what those are. I'm going to have x plus 7 equals 6, and that's going to tell me that x equals negative 1. And x plus 7 equals negative 6. That's going to tell me that x equals negative 13. I have 2 answers once again. There's one answer. There's my other answer. All right. The bottom one. If I've got x squared plus 2x plus 0 equals negative 3, again, my goal is to make this thing, sorry about the gap there, my goal is to make this thing into a perfect square. Okay, so if I take my b and divide it by 2, I get 1, and then I square it, and I wish there were a 1 there. But there's a 0. How can I make that a 1? I can add 1. X squared plus 2x plus 1 equals, if I add a 1 to the left, I've got to add a 1 to the right. Negative 3 plus 1 is negative 2. My left side factors into x plus 1 squared. I can take the square root of both sides. I got x plus 1 equals square root of plus or minus I times the square root of 2. X is going to equal plus or minus I times the square root of 2 minus 1 after I get that x by itself. Next thing I ask you to do is to write the quadratic formula. You will not have to do this on your spiral tomorrow. I will provide this for you. We learned two different forms of the quadratic formula today. One was negative b over 2a, plus or minus the square root b squared minus 4ac all over 2a. And that's a fine way to write that. The other way you could write that is x equals negative b plus or minus the square root b squared minus 4ac. None of that came out. I'm going to slide over a little bit. Minus 4ac all over 2a. I don't really care which version that you use. You just got to be able to plug some stuff in. Okay. My first equation, I've got 2x squared plus 9x plus 1. A equals 2, B equals 9, C equals 1. Okay, negative 9 plus or minus the square root. 81 minus 4 times 2 times 1 all over 2 times 2. Let's see what we can reduce. Okay, 81 minus 8 is going to be 73. Negative 9 plus or minus square root of 73 all over 4. Since 73 does not have a clean square root, we are done. I'd like you to notice you still have your two answers. You have negative 9 plus the square root of 73 over 4 and negative 9 minus the square root of 73 over 4. Next problem. My A is going to be 3, B is going to be negative 4, and C is going to be 2. Okay? I'm going to use x equals negative b, so negative negative 4, plus or minus the square root, b squared, so negative 4 quantity squared, minus 4 times a is 3, times c is 2, all over 2 times a is 3. Cool. Let's do some mathing stuff now. We get a positive 4, negative negative. Okay, plus or minus. 4 squared is 16. 4 times 3 is 12. Times 2 is 24, minus 24. That's all over 6. I'm going to slide over a little bit. And I'm going to end up with 4 plus or minus 16 minus 24 is negative 8 all over 6. This is going to give us 4 plus or minus the square root of 8 times I all over 6. With that, we have two answers. We have the plus and we have the minus. You could reduce this a little bit further, but I'm not going to ask you to. The square root of 8 can be reduced into 2 square roots of 2, so you'd get 4 plus or minus 2 square roots of 2 times I all over 6. Now I have a bunch of stuff that's even that I can reduce, and I get 2 plus or minus root 2 I all over 3. This would be the most reduced form of this problem, but you do not need to go that far. Thanks for trying to study for this, and I wish you good luck tomorrow.